All right, let's dive in. Number 10. Pachycrocuta. In 1929, deep inside the limestone caves of Zhoukoudian near Beijing, paleontologists uncovered what looked like one of the greatest human sights ever found. Broken skulls of Homo erectus, stone tools, burn marks, layers of occupation stretching back hundreds of thousands of years. For decades, the cave was described as a home, a refuge, a place where early humans gathered around fire while Ice Age winds scraped across northern China. Then the bones were studied more closely. Human femurs had the same tooth punctures as deer. Skull fragments carried crushing marks powerful enough to split thick cortical bone like dry wood. Entire skeletons were missing their softer ends, exactly the pattern seen in modern carnivore dens. And scattered through the cave floor were fossilized droppings from an animal weighing nearly 200 kilograms. Not wolves, not lions, giant hyenas. Pachycrocuta brevirostris stood taller at the shoulder than a modern spotted hyena, and carried jaws capable of generating more crushing force than a polar bear. Its premolars were shaped like industrial presses. In 2004, anthropologist Noel Boaz and colleagues argued that Zhoukoudian may not have been primarily a human shelter at all. It may have been a feeding ground, a place where giant hyenas dragged human bodies into darkness. The famous Peking Man Cave may have doubled as a predator's pantry. That changes the emotional picture completely. The cave was cold, wet, and saturated with the smell of decay. Water dripped endlessly from the ceiling. Bones cracked under paws. Somewhere in the dark, cubs squealed and fought over marrow, while adult hyenas crushed limb bones with a sound like snapping branches. Early humans entering that system were not masters of the landscape. They were meat moving through it. And Pachycrocuta was built for exactly that world. Unlike the spotted hyenas alive today in Africa, this species was massively heavy. Estimates place some individuals near 200 kilograms, nearly triple the weight of many living hyenas. The skull alone could exceed 40 centimeters. Bite force reconstructions suggest it specialized in pulverizing bone to extract marrow, one of the richest calorie sources available during the Pleistocene. Fossil assemblages from Eurasia show the same pattern again and again. Broken herbivore skeletons, cracked skulls, gnawed limb ends, and occasionally, human remains mixed into the debris. The unsettling part is how intelligent these predators probably were. Modern hyenas outperform several primates in cooperative problem-solving tests. They recognize social rank, remember alliances, and coordinate hunts across large distances. Pachycrocuta likely inherited much of that cognitive toolkit. A pack waiting near a cave entrance in fading evening light would not have been random chaos. It would have been organized pressure, and Homo erectus was vulnerable. They had fire, but not always. They had stone tools, but no projectiles, no walls, no secure shelters. A sick individual, a child separated from the group, even a sleeping adult near the edge of camp could become an opportunity. Predation pressure shaped human evolution long before humans became apex predators themselves. Fear sharpened hearing. Fear encouraged cooperation. Fear kept fires burning at night. Human intelligence may have evolved partly because something wanted to eat us. That idea sits underneath nearly every fossil layer from the early Pleistocene. We often reconstruct prehistory as a steady march upward, sharper tools, larger brains, expanding territories. But evolution does not move through triumph alone. It also moves through panic, through screams in darkness, through the instinct to glance over your shoulder before drinking water. And Pachycrocuta represented a nightmare perfectly adapted to exploit hesitation. Its range stretched from Europe to Asia. It survived dramatic climate swings. It competed with saber-toothed cats and giant bears, and still dominated carcasses through sheer mechanical power. Some paleontologists think it functioned less like a scavenger and more like an active kleptoparasite, stealing kills from other predators through intimidation. If true, early humans were facing an animal that could overpower almost anything in its ecosystem simply by arriving. There is a line hidden inside the Zhoukoudian evidence that feels disturbingly modern. Humans were not studying the cave was studying humans. The deeper archaeologists looked, the more the hierarchy flipped. The species that eventually mapped the genome, split the atom, and walked on the moon once spent nights listening for padded footsteps beyond firelight, knowing that somewhere nearby, jaws strong enough to crack a horse femur could close around a human skull just as easily. Number 9. Gigantopithecus, the ape that disappeared into the bamboo dark. In 1956, inside a humid cave system in southern China, paleontologist Pei Wenzhong examined a collection of fossil teeth so massive they looked almost fabricated. One molar measured more than 2 centimeters across, thick enamel, roots like stone pegs. Nearby lay fragments of a gigantic jaw, curved and heavy enough to belong to something far beyond any living ape. For years, the animal was imagined as a peaceful giant, a vegetarian hidden in misty forests, slowly chewing bamboo while early humans evolved elsewhere. Then came the protein evidence. In 2024, researchers analyzing enamel chemistry and microscopic wear patterns published data suggesting Gigantopithecus blacki was not the simple bamboo specialist scientists once pictured. The teeth carried signatures of a flexible diet, fruit, tough vegetation, possibly meat. The forests of Pleistocene Asia were crowded ecosystems where Homo erectus, giant pigs, orangutans, crocodiles, and massive cats competed for calories beneath dense subtropical canopies. And in ecosystems like that, size changes behavior, especially at 500 kilograms. A modern silverback gorilla can tear apart banana trunks with bare hands. Gigantopithecus may have weighed nearly twice as much. Standing upright, some estimates push it close to 3 meters tall. Its forearms were likely thick with tendon and muscle built for climbing and pulling. Every movement through wet undergrowth would have produced deep cracking sounds, branches snapping under enormous weight. Not fast, not elegant, just overwhelming. And Homo erectus was sharing those forests. That matters because early humans in Asia were not carrying metal weapons or organized defenses. They moved in small groups. They foraged along riverbanks. They slept lightly. The forests around them were hot enough to steam after rainfall, filled with the smell of wet soil and rotting fruit. Cicadas screamed in the canopy. Visibility collapsed beyond a few meters of foliage. Something large could stand motionless behind vines and remain invisible. The old image of human evolution often treats intelligence as an automatic advantage. Bigger brains, sharper tools, expanding territory. But intelligence develops inside pressure, and a giant omnivorous ape creates a very specific kind of pressure: close-range violence. Primates already kill primates. Chimpanzees conduct territorial raids. Baboons steal infants from rival groups. Orangutans have been documented hunting slow lorises. Humans like to imagine a moral wall separating us from other apes. Yet the fossil record keeps dissolving it. Gigantopithecus existed inside that same evolutionary landscape. Large-bodied primates are not automatically gentle simply because they eat plants most of the time. A gorilla can crush a leopard's skull. A male chimpanzee can remove a human face with its teeth. Now scale that upward. One broken branch overhead. One scream. One ambush near water. The terrifying part is that evidence of predation rarely fossilizes cleanly in rainforest environments. Acidic soils erase bone. Heat accelerates decay. Entire dramas vanish before geology can preserve them. Scientists do not possess a skeleton showing Gigantopithecus actively killing a hominin. What they do possess is coexistence, anatomy, dietary flexibility, and ecological logic. A 500-kilogram ape competing for survival beside small, vulnerable humans would not have behaved like a zoo exhibit. And Homo erectus would have understood that immediately. You can feel it in the geography. Southern China during the Pleistocene was not open savanna where danger could be seen from kilometers away. It was layered green darkness. Ferns taller than humans. Mud sucking at ankles. Air thick enough to taste. Leeches clinging to skin after crossing streams. Predators did not need speed there. They needed surprise. Gigantopithecus may have relied on exactly that. Its extinction around 300,000 years ago appears linked partly to climate change. Forests fragmented. Food sources shifted. The giant ape seems to have specialized too slowly for a rapidly changing environment. Homo erectus survived. Later humans survived. The forests that once hid enormous primates gradually transformed into ecosystems favoring smaller, more adaptable species. But extinction does not erase influence. Every predator leaves fingerprints on the nervous systems of survivors. Humans still possess an instinctive fear of large forward-facing eyes emerging from darkness. Sudden branch snaps trigger adrenaline before conscious thought catches up. Our brains react to looming primate shapes with unusual emotional intensity because for millions of years, another intelligent face in the forest could mean death. And Gigantopithecus forces an uncomfortable realization about human uniqueness. We like to place ourselves at the top of evolution's ladder, isolated from other animals by intellect. Yet, for most of prehistory, intelligence was not rare. We evolved among other clever creatures. Hyenas coordinated, ravens planned, cats stalked strategically. And somewhere in the steaming forests of Ice Age Asia, a giant ape with hands disturbingly close to our own may have watched human groups move through the trees and recognized them not as future masters of Earth, but as vulnerable competitors made of meat. Number 8. Haast's eagle. The shadow that fell straight down. Around 700 years ago, in the forests of New Zealand, something massive moved through the air without a sound. No wing beats, no warning. Just a pressure change, a sudden darkness, and then impact. The Maori remembered it as a bird that could seize children and never return them. For generations, those stories were treated as symbolic exaggeration. Spirits, metaphors, teaching myths meant to keep people close to the village. Until bones proved otherwise. In 2005, geneticist Michael Bunce and his team extracted ancient DNA from fossil remains of a gigantic raptor buried in limestone caves and swamp sediments across the South Island. The results, published in PLOS Biology, confirmed what anatomy had already suggested. This was not folklore inflated by fear. This was a real predator. Harpagornis morii, better known as Haast's eagle, the largest eagle ever to live. It weighed up to 15 kilograms. That number sounds modest until you add the wings. A wingspan approaching 3 meters. Broad, muscular flight feathers built for short, explosive bursts rather than long glides. Talons the size of tiger claws, curved and thick, capable of punching through muscle and bone. And most importantly, a skull engineered for impact. The beak was not delicate. It was reinforced, hooked, and designed to kill quickly. Haast's eagle evolved in an ecosystem with no land mammals larger than a dog. Instead, New Zealand's forests were dominated by moa, flightless birds weighing up to 230 kilograms. The eagle adapted to hunt them. It attacked from above, striking the back of the neck or pelvis at speeds estimated over 80 kilometers per hour, using its talons to rupture organs and collapse the spinal cord. A single blow could kill prey more than 10 times the eagle's own mass. Then humans arrived. Polynesian settlers reached New Zealand around the 13th century. They brought dogs. They brought fire. They hunted moa relentlessly. And they entered a landscape where the apex predator did not stalk on the ground or roar from a distance. It came from the sky. The forests where Haast eagle hunted were cool and damp, filled with the smell of moss and decaying leaves. Sunlight broke through the canopy in narrow shafts. Ferns brushed against legs as people moved between trees. The air carried bird calls and the distant sound of wind moving high above, where danger could not be seen. An eagle perched silently does not announce itself. Feathers muffle sound. Gravity does the rest. This is where the myth intersects with biomechanics. Based on muscle attachment scars and modern eagle analogs, Haast eagle could exert several hundred kilograms of force through its feet. Its inner talon alone measured nearly 8 centimeters. That is long enough to penetrate the human chest cavity. Unlike mammalian predators that must chase, grapple, or bite, an eagle attacks with kinetic energy. The damage is immediate. There is no warning growl, no time to react. Skeletal evidence supports the stories. Maori archaeological sites contain carvings and oral histories describing a bird called Te Hokioi or Poakai, a creature of terror associated with sudden death. Some cave sites preserve eagle bones alongside human remains, not in ceremonial contexts, but scattered, broken, and mixed with food debris. The relationship was not symbolic, it was ecological. Humans were prey. This overturns a comforting assumption about human dominance. We often imagine that once Homo sapiens arrived, the hierarchy flipped instantly. Tools, fire, cooperation, end of story. But Haast's eagle did not need to understand tools, it needed vulnerability. A lone person in a clearing, a child near the forest edge, a moment of distraction. And for roughly a century, that was enough. The extinction of Haast's eagle came fast. Once the moa were gone, its primary food source vanished. Large eagles reproduce slowly, 1 or 2 chicks, long maturation. With forests burned and prey eliminated, the species collapsed within a few human generations. By the time Europeans arrived, the sky predator had already disappeared, leaving only stories and scattered bones. But the psychological footprint lingered. Humans evolved to fear terrestrial hunters. Eyes in grass, shapes behind rocks. Haast's eagle added a different dimension, vertical threat. A predator that bypassed all defenses by attacking from above. Even today, people instinctively flinch at large shadows crossing overhead. Sudden changes in light trigger reflexes older than language. Our neck muscles tense. Our eyes jump skyward. Those reactions were calibrated in places like prehistoric New Zealand. The unsettling lesson here is not that humans were weak, it is that the world was more inventive than we like to remember. Evolution produced predators that exploited every axis of space: land, water, trees, and air. For a brief period, humans shared their environment with an animal that could kill them in silence, using gravity as a weapon. Haast's eagle forces a recalibration of perspective. We were not always the watchers. Sometimes we were the shapes moving below, unaware that intelligence, muscle, and lethal precision were already aligned above us, waiting for the exact angle where resistance no longer mattered. Number 7. Titanoboa, the snake that turned rivers into traps. In 2009, inside the Cerrejón coal mine in northern Colombia, Paleontologist Jonathan Block stood in air so humid it felt liquid. Sweat soaked through clothing within minutes. The ground smelled of sulfur, wet clay, and rotting vegetation exposed by excavation machines cutting through ancient rock. Workers had already uncovered gigantic fossil turtle shells and crocodilian vertebrae. Then came the snake bones. At first, the vertebrae made no sense. Each one was enormous, thick as a clenched fist, too large for any living serpent. As more segments emerged from the sediment, scientists realized they were reconstructing something the modern world no longer contains: a snake longer than a city bus. Titanoboa cerahonensis, roughly 13 meters long, more than a metric ton in weight, the largest snake ever discovered. And unlike dinosaurs, this thing belonged to a world surprisingly close to ours. Titanoboa lived around 58 million years ago, after the asteroid impact that erased non-avian dinosaurs. Mammals were beginning to diversify. Early primate relatives already moved through tropical forests. Tiny, vulnerable, warm-blooded creatures with grasping hands and forward-facing eyes. Not human yet, but close enough to trigger an uncomfortable thought. Before mammals ruled the canopy, the rivers were already ruled by something capable of swallowing them whole. The old image of giant prehistoric predators usually centers on teeth and speed. Tyrannosaurs charging, saber-toothed cats ambushing. Titanoboa breaks that pattern completely. Snakes do not kill through claws or pursuit. They kill through physics, pressure, compression, silence. Modern studies of boa constrictors and anacondas show that constriction does not primarily suffocate prey. It shuts down circulation. Every exhale tightens the coils slightly more until blood flow collapses. The heart cannot recover. Consciousness disappears in seconds. Death follows quickly after. Titanoboa scaled that mechanism upward to monstrous proportions. Researchers estimate its body diameter may have exceeded 1 meter at the thickest point. Imagine the force generated by layers of muscle wrapping around ribs, spine, lungs, arteries. A struggling animal would not hear bones snapping dramatically like in movies. Real constriction is quieter. Wet cracking sounds, air forced from lungs, mud churning beneath thrashing limbs. Then, stillness. Cerrejón during the Paleocene was brutally hot. Average temperatures may have exceeded 30 degrees Celsius year-round. Dense rainforests stretched across swamp systems, tangled with giant ferns and broadleaf plants dripping with condensation. Insects screamed continuously. Rivers moved slowly under brown surfaces reflecting almost no light. The humidity was so extreme that large, cold-blooded predators could maintain enormous body mass because the environment itself functioned like a permanent incubator. Titanoboa was not chasing prey through open ground. It was waiting in water. That matters because aquatic ambush predators create a different kind of fear. Mammalian hunters often reveal intent, a charge, a roar, movement in grass. But river predators erase the boundary between safe terrain and death. The water looks calm right until it explodes. Modern green anacondas already attack deer, caimans, jaguars, and occasionally humans. Nile crocodiles still kill hundreds of people every year using similar ambush mechanics. Titanoboa existed at the extreme endpoint of that strategy. Fossil evidence found alongside its remains includes giant fish, turtles, and crocodilians, some large enough to challenge modern apex predators by themselves. Yet isotope analysis and jaw mechanics suggest Titanoboa preyed on them regularly. A 1-ton snake eating crocodiles. That sentence alone destabilizes scale. Scientists debate exactly how active Titanoboa was on land. Its vertebrae resemble aquatic boas more than fast terrestrial pythons. The consensus points toward a semi-aquatic lifestyle, similar to modern anacondas but vastly larger. Which means early primates moving through Paleocene forests face danger not from pursuit across terrain, but from invisible mass hidden beneath opaque rivers. And primates are drawn to water constantly. Water means cooling, food, migration routes, safety from some predators. Even today, chimpanzees cautiously approach riverbanks while scanning for crocodiles. Human children instinctively play near water despite danger. Evolution pulls intelligent mammals toward rivers because survival depends on them. Titanoboa transformed that necessity into a hunting advantage. One slip into dark water, one ripple, one impact from below. The terrifying part is mechanical inevitability. Against claws, there is struggle. Against teeth, there is escape if wounds are survivable. Against constriction at Titanoboa's scale, resistance becomes mathematically irrelevant. Muscle overcomes oxygen, circulation fails, the nervous system shuts down. Predation becomes engineering. And Titanoboa reveals something important about Earth after the dinosaurs vanished. We tend to picture mammalian evolution as a triumphant ascent once giant reptiles disappeared. But the fossil record says otherwise. For millions of years after the extinction event, reptiles still dominated many ecosystems. Giant snakes, giant crocodilians, massive flightless predators. Mammals did not inherit the planet cleanly. They survived inside worlds where becoming prey remained the default condition. Eventually, Earth cooled. Tropical ecosystems contracted. Giant, cold-blooded bodies became harder to sustain. Titanoboa disappeared because climate itself no longer allowed that scale. Physics changed with temperature. The planet closed a biological window that once permitted rivers to contain living muscle longer than a truck. But our nervous systems still remember the pattern. Humans across nearly every culture fear snakes instinctively. Infants detect serpentine shapes faster than flowers or neutral objects. Our eyes lock onto coiled patterns before conscious recognition. Neuroscientists studying visual processing believe snake detection may be one of the oldest specialized threat systems in primate evolution. Long before cities or language, something in the trees learned that curved motion near water could mean instant death. Titanoboa sits at the origin of that nightmare. Not because humans ever encountered it directly, but because creatures close to our lineage almost certainly did. Small primates peering over swamp edges, tiny hearts accelerating at sudden ripples, brains wiring themselves for vigilance around water and scaled movement. Fear can survive longer than the animal that created it. And somewhere beneath the steaming forests of ancient South America, hidden under black river water thick with sediment, evolution once produced a predator so large that the boundary between snake and landscape almost disappeared entirely. Number 6. Arctodus simus. The predator you could not outrun. Near Fairbanks, Alaska in 1993, paleontologist Richard Harrington examined a massive fossil paw recovered from permafrost sediments along the Yukon River basin. The claws alone curved nearly 15 centimeters. Nearby were fragmented bison bones carrying deep scoring marks and shattered joints. At first glance, the scene resembled an ordinary Ice Age kill site. Then, researchers reconstructed the animal's height. Standing upright, it could reach 3.5 meters. The short-faced bear, Arctodus simus, was not merely a larger version of modern bears. It was built according to a different logic. Long legs, a shortened snout, enormous shoulders rising like a wall of muscle above the spine. Estimates vary, but some males may have approached 1,000 kilograms. And unlike the slow, lumbering stereotype attached to giant bears, Biomechanical studies suggest Arctodus was astonishingly fast across open terrain, possibly 60 kilometers per hour. That changes the emotional geometry immediately. Most predators allow for a fantasy of escape. You climb, you hide, you outrun them. Ice Age North America offered no such comfort. Around 50,000 years ago, the first humans entering Beringia crossed into landscapes already occupied by one of the most physically intimidating mammals evolution ever assembled. Winds swept across frozen grasslands carrying the smell of snow and animal fat. Herds of steppe bison moved through valleys under skies so clear they seemed metallic. And somewhere beyond the ridgelines, a bear taller than a basketball hoop could cover ground faster than a galloping horse. The frightening part is not merely size, it is efficiency. Modern grizzly bears are heavily built for mixed environments: forests, rivers, ambush encounters. Arctodus appears adapted for distance. Limb proportions indicate long-range movement over huge territories. Some paleontologists originally proposed it functioned mainly as a scavenger, using speed and intimidation to steal carcasses from saber-toothed cats and direwolves. But later isotopic analysis complicated that picture. Nitrogen signatures in fossil bones place Arctodus extremely high in the food chain, consistent with regular meat consumption rather than occasional scavenging. This thing hunted, and it hunted in a world crowded with other apex predators. North America during the late Pleistocene already contained American lions, packs of direwolves, saber-toothed cats, and giant hyenas. Yet Arctodus still became one of the dominant forces on the continent. That requires more than bulk. It requires behavioral supremacy. A predator capable of approaching an active kill site and forcing everything else away through sheer threat display. Imagine the sound first. Heavy footfalls compressing frozen soil, wet breathing in cold air, claws scraping rock. Modern bears already produce an unsettling combination of intelligence and violence because their faces resemble ours more than feline predators do. Their eyes track carefully. Their posture shifts unpredictably between animal and almost human. Arctodus amplified that discomfort into something monstrous. Its skull looked wrong. The snout was shorter and broader than expected, giving the head a compressed appearance that increased bite leverage. Shoulder muscles attached to enormous bony ridges along the spine. Even fossilized, the skeleton communicates force. Researchers reconstructing its gait noticed something else disturbing. Unlike cats, which explode in short ambushes, or wolves, which exhaust prey gradually, Arctodus may have relied on relentless pursuit over open ground. Not faster for a moment, faster for long enough. That matters because the first humans entering North America were endurance specialists. Homo sapiens survived partly through persistence hunting, tracking prey over hours until animals collapsed from overheating or exhaustion. Against most mammals, human cooperation and stamina became evolutionary advantages. Arctodus potentially inverted the equation. It was one of the few terrestrial predators large enough, fast enough, and mobile enough to turn endurance against us. You cannot persistence hunt something that does not tire before you do. Fossil sites across Alaska, Yukon Territory, and the western United States reveal repeated overlap between Arctodus habitats and early human migration corridors. Cut-marked animal bones found near bear remains suggest competition over carcasses. In several cave systems, enormous bear skeletons appear alongside traces of human occupation, separated by surprisingly narrow time windows. The message is uncomfortable. Humans were not moving into empty wilderness. They were negotiating territory with predators already optimized for domination. And unlike lions, bears investigate. Modern brown bears routinely approach campsites, test unfamiliar smells, overturn objects, and learn behavioral patterns rapidly. Intelligence increases danger because curiosity eliminates predictability. A wolf may fear fire consistently. A giant bear might decide to approach anyway. The Ice Age environment intensified every encounter. Winter temperatures in Beringia could plunge below -40 degrees Celsius. Breath crystallized instantly. Skin cracked from dry wind. Firewood remained scarce across open tundra. At night, sound traveled enormous distances through frozen air. A snapped branch or distant growl carried across kilometers. Humans clustered tightly around flames because darkness beyond the firelight was not metaphorically dangerous. It was biologically occupied. Then there is the face-to-face scenario. Standing upright was likely not an attack posture at first. Bears rise to investigate scent and visibility. But when Arctodus stood, early humans would have seen a moving vertical mass larger than any primate nervous system was designed to process calmly. The chest alone could block out stars behind it, saliva steaming in freezing air, black nose wet with condensation, claws reflecting orange firelight. Fear at that scale becomes physical paralysis. Mateus and other paleobiologists studying Arctodus argued that even if it scavenged frequently, scavenging itself can shape ecosystems through intimidation. A predator does not need to kill constantly if everything else abandons food when it arrives. Humans carrying stone tools and wooden spears may have defended kills occasionally, but every confrontation carried catastrophic risk. One broken leg in Ice Age tundra was effectively a death sentence. Eventually, Arctodus vanished around 11,000 years ago as climates warmed and megafauna populations collapsed. The giant herbivores it depended on disappeared one by one. Mammoths dwindled, ancient bison changed range, ecosystems fractured. Humans survived the transition because adaptability is our species' greatest weapon. But adaptability is not dominance. Arctodus simus exposes a forgotten chapter when intelligence alone did not guarantee authority. There were moments in prehistory when a human standing on open ground represented neither hunter nor ruler, but moving meat temporarily protected by fire and numbers. And somewhere in the cold silence of Ice Age America, evolution once produced a bear large enough to make even confident humans understand a brutal truth. There are predators that do not merely threaten your survival, they erase the idea that escape was ever possible at all. Number 5. Stephanoaetus. The eagle that left fingerprints inside a child's skull. In 1924, at a limestone quarry near Taung in South Africa, anatomist Raymond Dart opened a small fossilized skull packed in hardened breccia. Dust filled the air as workers smashed rock with picks under brutal heat. The skull belonged to a juvenile Australopithecus africanus, a child around 3 or 4 years old. Dart immediately recognized something extraordinary. Rounded cranium, forward-facing eyes, human ancestry preserved in stone. But decades later, another detail emerged that changed the fossil completely. The eye sockets contained puncture marks, tiny, precise, V-shaped. In 2006, paleoanthropologists Lee Berger and Ronald Clark compared those marks with damage patterns found on modern primates killed by African crowned eagles, Stephanoaetus coronatus. The similarities were horrifyingly exact. Talon penetration through the orbits, skull fractures matching beak-feeding behavior, damage concentrated at points where raptors grip struggling prey. The famous Taung Child may not have died from disease, starvation, or accident. It may have been carried into the sky alive. That possibility matters because humans instinctively fear predators approaching from ground level. Mammalian brains evolved to track movement in grass, shadows between trees, sounds behind us. But aerial predation attacks the nervous system differently. There is almost no warning. One moment the forest is still except for insects and wind. Then branches explode overhead. and something drops. Modern crowned eagles are already among the most powerful avian predators on Earth. Adults weigh around 5 to 6 kilograms, yet they regularly kill monkeys heavier than themselves, bush babies, vervets, young antelope. In documented attacks, they strike with enough force to crush skulls instantly. Their talons can exceed the grip pressure of a lion's jaws per square centimeter. Forest trackers in Uganda describe hearing the impact before they see the bird. A heavy thud in leaves, screaming, then silence. Now scale that into the Pliocene. Around 2.5 million years ago, southern Africa was a mosaic of woodland, open savanna, and rocky escarpments. Early hominins moved through fragmented forests, carrying no weapons beyond sticks and stones. Juveniles were especially vulnerable. Their heads were large relative to body size, their limbs still clumsy. Adults could defend against some terrestrial predators through numbers and vigilance. But eagles bypass defenses vertically. Researchers studying modern crowned eagle nests have found remains from dozens of primate species beneath feeding sites. Bones stripped clean. Small skulls cracked open with surgical efficiency. The birds prefer arboreal prey because forest canopies allow surprise attacks from above. Australopithecines likely occupied similar ecological zones. They climbed trees. They nested near woodland cover, which means they entered the hunting territory of giant raptors constantly. And the Taung Child was exactly the right size. The attack itself was probably terrifyingly fast. A crowned eagle dives at speeds exceeding 100 kilometers per hour through dense forest. Wings fold partially backward to avoid branches. Talons extend milliseconds before impact. Modern victims often show puncture wounds around the face and cranium because eagles target the head immediately to disable struggling prey. Berger's team noticed the Taung's skull displayed identical trauma patterns to monkeys killed by modern raptors in Ivory Coast. Evolution preserved the murder weapon across millions of years. There is another disturbing detail. Eagles do not always kill instantly. Large prey can remain conscious during transport. Wildlife researchers have documented monkeys screaming while being carried into trees, talons embedded through shoulders and skull. Imagine the sensory chaos for an early hominin child. Sudden compression around the head, wind roaring in ears, the ground falling away through branches, sunlight flickering through leaves while adults below scream helplessly upward. Primate intelligence becomes useless once gravity changes sides. For years, many anthropologists resisted the eagle hypothesis because it violated an old assumption about human evolution. The dominant image placed early humans gradually ascending the food chain through intelligence and tool use. But fossil evidence across Africa paints a far less triumphant picture. Hominins were prey animals for much of their existence. Leopards dragged them into caves. Crocodiles crushed them at riverbanks. Hyenas chewed their bones. And sometimes the sky hunted them. Stephanoaetus forces an uncomfortable realization about the origin of human childhood itself. Modern human infants require extraordinary protection compared to other mammals. Adults monitor constantly. We instinctively react to shadows overhead. Children fear being grabbed, lifted, taken. Some evolutionary psychologists argue that raptor predation may have shaped primate social behavior far more deeply than previously understood. Alarm calls in monkeys differ depending on whether danger comes from ground, snake, or sky. Each triggers distinct reactions automatically. Certain fears became hardwired because hesitation meant death. Even today, crowned eagles occasionally attack human children in parts of Africa. Rarely, but enough to matter. In 1988, a 7-year-old boy in South Africa survived an eagle attack, only because nearby adults intervened quickly. Witnesses described the bird striking silently from behind before attempting to carry the child away. Modern humans, armed and organized, still remain within the behavioral target profile of these predators. That continuity across millions of years is chilling. The Taung Child fossil sits in museums now under soft artificial lighting. Visitors stare at the delicate skull, searching for humanity in its features. Rounded forehead, small teeth, familiar eyes. But inside those orbits remain marks left by claws descending from above, long before civilization, language, or memory. Predation etched directly into the face of one of our ancestors. And perhaps that is why sudden shadows still trigger something ancient inside the human nervous system. Birds crossing overhead, large wings blotting out sunlight for half a second, the reflexive glance upward, the acceleration of pulse before conscious thought catches up. Because somewhere near the beginning of human awareness, evolution taught our lineage a brutal lesson. The ground was never the only place death could wait. Number 4. Megalania, Queensland, Australia, 1909. A station hand walking a dry creek bed near the Darling Downs kicks at something pale lodged in the clay. It is a tooth, curved, serrated along the back edge, longer than his thumb. He pockets it, thinking crocodile. He is wrong by an order of magnitude. That tooth, and dozens like it pulled from Pleistocene deposits across the continent, belongs to Varanus priscus, better known by its older name, Megalania. A monitor lizard that grew past 5 meters, possibly closer to 7 in the largest individuals, and weighed somewhere between 500 and 1,000 kilograms, depending on which reconstruction you trust. The first people to set foot in Australia, roughly 65,000 years ago by the dates from Majed rock shelter, walked into a continent where the apex predator was a lizard the length of a minibus. The science took a hard turn in 2009. Stephen Rowe and Brian Fry, working with colleagues at the University of Melbourne and the University of Queensland, published in the Journal of Anatomy and followed up in PLOS 1 with Scott Hocknull's team, demonstrating that the Komodo dragon, Megalania's smaller living cousin, carries genuine venom glands. Paired ducts in the lower jaw, secreting anticoagulants and hypotensive compounds that drop blood pressure, prevent clotting, induce shock. The old story of Komodo bites killing through bacterial sepsis was wrong. The animal is venomous, and every anatomical signal Megalania left behind, the same jaw architecture, the same tooth morphology, the same skull mechanics, says it carried the same machinery, scaled up. A bite from a 7-meter monitor would not need to kill on contact, it would only need to land. The old view held Megalania as a scavenger, a slow giant cleaning up after the marsupial lions and the thylacines. That view collapsed under the weight of the bite mechanics, the cursorial leg proportions in some specimens, and the simple fact that the animal coexisted with humans. Radiocarbon dates from Cuddy Springs in New South Wales, contested but published by Judith Field and her team, place Megalania remains in sediments dated to around 40,000 years ago, overlapping the human arrival window by tens of thousands of years. Hocknull's 2009 paper laid out the ambush ecology in detail. The lizard hunted from cover, dry scrub, billabong margins, the thick paperbark stands along seasonal rivers. It struck once, released, and tracked. The prey, a diprotodon, a giant kangaroo, a hominin, would bleed internally for hours, sometimes days before collapse. The lizard followed at a walk. Consider the sensory reality of that landscape. Heat shimmer rising off red dirt in the late afternoon. The dry rattle of cicadas, then silence, then the rattle again. The smell of eucalyptus resin baked into the air until it stings the back of the throat. A small band of humans moving along a creek line, looking for water, eyes on the ground for tracks, for snakes. The lizard does not move. It does not need to. Its skin matches the bark, the leaf litter, the broken shadow under a low branch. The first warning is the sound of the strike itself, a sudden heavy displacement of leaves and gravel, and then the impact. After that, the venom does the work the muscle started. The evidence for direct predation on humans is circumstantial, by necessity. Skeletons of the first Australians are vanishingly rare. The acidic soils of the continent destroy bone within a few thousand years in most settings. But the inference is solid on ecological grounds. Tim Flannery laid it out in The Future Eaters in 1994. Any large mammal entering Australia during the late Pleistocene entered the hunting range of Megalania. Children, the elderly, the injured, anyone moving alone along water margins was within the prey size class the animal already targeted. The extinction of Megalania, somewhere between 50 and 40,000 years ago, lines up uncomfortably well with the spread of human populations across the continent. Two predators, one ecological role, one of them with fire and coordinated spears. There is something specific about being hunted by a reptile that human cognition struggles with. Mammalian predators have faces we read. A wolf telegraphs intent through ears, lips, posture. A big cat fixes its gaze. The lizard offers none of that. The eye is flat. The face does not change. The animal that is about to kill you looks exactly the same as the animal that is digesting in the shade. Australian Aboriginal cultures carry stories of enormous reptiles in the landscape, the rainbow serpent among them. And while no anthropologist claims a direct memory of Megalania across 40,000 years, the persistence of giant reptile motifs in the oldest continuous oral tradition on Earth is not nothing. Memory has strange depths. The philosophical weight here is the indifference. Mammalian predators evolved alongside us, read us, sometimes hesitate. The reptile does not hesitate and does not read. It registers temperature, motion, mass. The first Australians walked into a country governed by a mind that did not recognize them as anything other than warm meat moving through grass. And for 25,000 years, that mind won often enough to keep its lineage alive. Then it stopped winning. The lizard vanished. The grass kept moving. Number 3. Dinopithecus. The moment another primate looked at early humans and saw prey. In 1937, inside cave deposits near Makapansgat in South Africa, paleontologists uncovered fragments of a baboon unlike anything alive today. The jaws were too thick. The teeth looked oversized, even beside those of modern mandrills. Limb bones suggested terrifying strength. As more fossils emerged across the 20th century, researchers realized they belonged to an extinct giant primate called Dinopithecus ingens, a baboon so massive that adult males may have weighed over 70 kilograms, nearly 3 times heavier than living baboons. And it lived beside early humans. That detail changes the entire emotional texture of prehistory. Humans are accustomed to seeing monkeys as noisy scavengers, clever thieves, tourist attractions stealing fruit from backpacks. But large primates operate frighteningly close to us behaviorally. Their eyes track intention. Their social groups coordinate attacks. Their aggression feels disturbingly familiar because the nervous systems behind it are variations of our own. Predation becomes psychologically different when the predator resembles you. Around 2 million years ago, southern Africa was unstable terrain. Dry grasslands stretched between woodland patches, while seasonal rivers cut through volcanic stone. The air smelled of dust and wet vegetation after storms. Herds of antelope crossed open plains under constant pressure from cats, hyenas, crocodiles, and packs of hunting dogs. Early Homo habilis moved through this environment carrying primitive stone tools barely sharp enough to butcher carcasses. And somewhere nearby moved troops of giant baboons. Modern baboons already possess shocking levels of violence. Chacma baboons in Africa have been documented killing young antelope, attacking livestock, and occasionally hunting other primates systematically. In 2019, researchers in South Africa recorded baboons coordinating pursuit behavior against vervet monkeys, isolating weaker individuals before tearing them apart alive. Their canine teeth can exceed 5 centimeters. Their bite force rivals large predators. Adult males fight with enough savagery to rip open flesh and crush smaller skulls. Dinopithecus scaled that aggression upward dramatically. The fossil evidence suggests immensely robust jaws and neck muscles adapted for heavy chewing and violent combat. Unlike graceful arboreal monkeys, these animals were ground-dwelling powerhouses built for intimidation. Some anthropologists once argued they were mostly herbivorous because of dental wear patterns. But modern primate ecology destroyed the comforting assumption that plant eaters are harmless. Baboons are opportunistic omnivores. They consume roots, fruit, insects, reptiles, birds, mammals. And under pressure, primates hunt primates. That possibility becomes much darker when body size enters the equation. An adult Homo habilis stood roughly 1.3 meters tall, with relatively fragile limbs and limited weapon technology. Juveniles would have been even more vulnerable. Dinopithecus males likely outweighed many early humans substantially while moving in coordinated social groups. Imagine hearing barking calls erupt across dry woodland at dusk, branches shaking, heavy bodies crashing through brush, yellow teeth flashing briefly between shadows. Not a cat stalking silently, a troop approaching aggressively. The psychological terror of primate attacks differs from mammalian predation because the behavior feels intentional. Modern chimpanzee assaults on humans demonstrate this clearly. Survivors describe eye contact, pursuit, strategic targeting of vulnerable areas like faces, hands, and genitals. Primates understand suffering in ways most predators do not. Violence becomes social rather than purely nutritional. And baboons are among the most fearless primates alive. Even today, isolated people in parts of Africa occasionally experience aggressive encounters that feel almost prehistoric. Rangers in Botswana describe Chacma baboons attempting coordinated intimidation against humans carrying food. Farmers report males entering settlements and attacking dogs directly. In rare cases, baboons have kidnapped infant animals and mauled children. A modern male chacma weighs perhaps 30 kilograms. Dinopithecus may have doubled that. Researchers studying fossil assemblages near South African cave systems noticed something intriguing about predator dynamics during the Plio-Pleistocene transition. Early humans did not merely compete against carnivores. They existed inside overlapping networks of omnivorous intelligence. Hyenas understood group tactics. Large birds exploited vulnerability from above. And giant primates occupied many of the same ecological niches as hominins themselves. Competition became personal. Because both lineages relied on social cooperation, memory, and adaptability. There is a brutal irony hidden here. Human beings often frame evolution as a steady march away from animality toward reason. But Dinopithecus reveals a period when intelligence itself intensified danger. A lion kills because instinct drives efficient predation. A giant baboon troop could attack because it recognized weakness, opportunity, territorial intrusion, or social advantage. The closer a predator stands to humanity cognitively, the more disturbing its violence becomes. Fossil evidence from sites containing both hominin and large primate remains suggests these species repeatedly crossed paths around water sources and feeding zones. Waterholes in African dry seasons become ecological pressure cookers, mud smelling of rot and algae, insects swarming above stagnant edges, animals packed together under brutal heat while predators circle constantly. Modern baboons dominate such areas aggressively, harassing weaker species through sheer social pressure. Now enlarge the baboon until it can overpower a human directly and give it the confidence of numbers. The attack itself would likely have been chaos rather than precision. Screaming calls echoing through trees, dust exploding upward as bodies collide, hands grabbing limbs, crushing bites into shoulders or skull. Early humans armed with stones may have fought back successfully at times, but injuries alone could become death sentences before medicine. Infection, broken bones, loss of mobility in predator territory. Survival depended on cooperation escalating faster than fear. Some paleoanthropologists argue that competition with aggressive social primates may have accelerated human cognitive development itself. Greater vigilance, stronger group cohesion, enhanced communication, the need to predict hostile intentions from creatures behaviorally similar to us. Human intelligence may not have evolved only against climate or predators. It may have evolved partly because another intelligent primate forced us to become harder to kill. Dinopithecus eventually vanished as African ecosystems shifted and primate communities reorganized. Climate instability fragmented habitats. Human ancestors became taller, more coordinated, more technologically capable. The balance changed slowly, then permanently. But the psychological residue remains astonishingly intact. Look at modern human reactions to aggressive monkeys. The fear appears instantly, despite their smaller size. Teeth displayed in threat posture, direct eye contact, sudden lunges. Crowds panic because something ancient recognizes the danger immediately. Deep inside the primate nervous system sits an understanding millions of years old. A creature shaped like us can still trigger absolute terror. And perhaps that is the most uncomfortable revelation Dinopithecus leaves behind. Early humanity did not rise cleanly above the animal world through inevitable superiority. For a long stretch of evolutionary time, our ancestors moved through forests and river valleys, surrounded by other intelligent species, with hands, forward-facing eyes, social hierarchies, and the capacity for organized violence. Human beings were not alone near the top of the primate food chain, and for a while, another branch of the family may have hunted us with the same cold opportunism our own lineage would later turn against everything else on Earth. Number 2. Teratorns. The birds that made the first Americans look up in fear. In 1953, inside the La Brea tar pits in Los Angeles, paleontologists extracted a skull so large it barely resembled a bird at all. The beak alone stretched longer than a human forearm. Wing bones emerged black with asphalt, thick as carved wood. At first glance, the fossils looked almost theatrical, like props from a forgotten monster film, but they belonged to something entirely real. Teratornis mariami, one of the giant teratorns that ruled Ice Age skies across the Americas. And when researchers reconstructed the full animal, the scale became difficult to process rationally. Some species approached 7 meters in wingspan, larger than many small aircraft. For decades, scientists described teratorns as oversized scavengers, circling ancient carcasses beside vultures. That interpretation sounded comfortable. Dead eaters, opportunists, ecological cleanup crews. But later aerodynamic studies and comparisons with modern condors suggested a far more active predator. These birds possessed unusually strong necks, grasping feet, and flight mechanics adapted for long-distance soaring, combined with sudden descents toward live prey. The old image of a passive scavenger started collapsing. Because teratorns lived alongside the first humans entering North America, around 15,000 years ago, the American West looked alien compared to today. Massive ground sloths moved slowly through dry valleys. Mammoths crossed grasslands under cold blue skies, streaked with volcanic dust. Dire wolves fought around carcasses, while saber-toothed cats vanished into sagebrush at dusk. And above everything drifted enormous birds, riding thermal currents for hours without flapping once. The soundscape mattered. Wind moving through giant wings does not resemble ordinary birds. Modern condors already produce deep, rushing air currents, audible from surprising distances. Scale that upward toward a predator with wings spanning nearly the width of a city bus, and the sky itself begins to sound occupied. Early humans would have noticed immediately. Chatterjee and colleagues proposed in 2007 that large Teratorns may have combined soaring efficiency with predatory flexibility, unlike anything alive today. Their shoulder structure allowed extraordinary flight endurance. Their beaks could tear flesh rapidly, and unlike vultures, their feet retained grasping ability, potentially capable of pinning struggling prey. The exact hunting strategy remains debated, but the ecological implications are disturbing, regardless of whether they hunted actively every day or opportunistically whenever possible. Because humans entering new continents are vulnerable by definition. Small populations, limited shelter, constant movement through unfamiliar terrain, and children everywhere move slower than adults. The first Americans crossed landscapes filled with creatures evolution had never prepared humans to encounter. Giant cats, massive bears, camels, short-faced wolves. Then, overhead, shadows large enough to blot out sunlight briefly across open ground. Modern people instinctively underestimate aerial predators because few living birds can threaten adult humans directly. But prehistoric ecosystems operated under entirely different physical rules. A 7-meter wingspan changes behavioral mathematics. Even if Teratorns primarily targeted smaller animals, the psychological pressure alone would have been immense. Modern golden eagles occasionally attack young deer. Crowned eagles in Africa kill primates heavier than themselves. Harpy eagles can shatter monkey bones with their grip. Large flying predators specialize in exploiting moments of isolation and imbalance. One slip, one separated child, one injured traveler crossing exposed ground, and Ice Age skies held far larger hunters. There is another detail that makes Teratorns uniquely unsettling. Birds do not approach prey emotionally the way mammals often do. Mammalian predators hesitate, posture, evaluate risk socially. Raptors commit violently once attack begins. Modern eagle strikes happen with terrifying speed. Victims often report hearing nothing until impact itself. Aerial predation bypasses many warning systems the human brain evolved to monitor. You can hear footsteps behind you. You rarely monitor the sky continuously. Fossil evidence suggests Teratorns concentrated around coastlines, inland lakes, and migration corridors packed with animals seasonally. Those same environments attracted humans seeking water and game. Imagine dawn beside a Pleistocene shoreline, salt wind blowing cold against skin, the smell of wet mud and animal dung drifting from herds near shallow water. Above the fog, enormous silhouettes circle silently, waiting for weakness to reveal itself below. Not pterosaurs, real birds. The beaks alone create nightmare imagery. Unlike hooked eagle beaks optimized for precision tearing, Teratorn skulls suggest deeper puncturing capability. Some paleontologists compared aspects of their feeding mechanics to storks mixed with vultures. That sounds harmless until you remember how modern storks kill prey. Sudden, downward stabbing motions. Violent swallowing behavior. Animals disappearing whole into the throat. Now enlarge the bird beyond anything alive today. Some reconstructions suggest smaller prey could have been swallowed almost intact. And human infants occupy a horrifyingly relevant size category. Direct evidence of Teratorns attacking humans does not exist. That matters scientifically. But ecological overlap absolutely did exist. Human beings entered landscapes already dominated by giant opportunistic predators evolved without fear of us. The earliest Americans were not conquering heroes marching into empty wilderness. They were intrusive mammals walking into ecosystems where multiple apex species could overpower them effortlessly. That changes the emotional architecture of colonization entirely. Because survival depended partly on being noticed as little as possible, large soaring birds also create a subtler form of terror humans rarely discuss: visibility. Open landscapes become psychologically oppressive when something above can monitor movement across kilometers. Modern military psychology understands this deeply. Persistent overhead surveillance alters behavior even before violence occurs. Now replace aircraft with hungry animals operating through instinct refined across millions of years. Every open valley becomes exposure. Every distant circling shape demands attention. Some researchers believe Teratorns vanished partly because large mammal extinctions destabilized their food sources near the end of the Pleistocene. Human expansion likely accelerated ecological collapse through hunting pressure and habitat disruption. The skies gradually emptied. Giant shadows disappeared from migration routes. Within a relatively short evolutionary moment, the largest birds North America had ever produced were gone forever. But their existence leaves behind an uncomfortable realization. Human beings speak constantly about mastering the land: fire, spears, agriculture, walls. Yet for most of our history, the sky remained hostile territory. We could not patrol it, could not dominate it, could not even reliably predict what might descend from it. And for the first people entering the Americas, there were moments when looking upward revealed something so enormous, so silent, and so biologically unfamiliar that the boundary between bird and monster almost disappeared completely. Number 1. Crocodylus anthropophagus. The only predator in history literally named for eating humans. In 2010, paleontologist Christopher Brochu published a paper describing fossil crocodile remains from Olduvai Gorge in Tanzania, one of the most important early human landscapes on Earth. The animal already looked enormous from the fragments alone: thick armored skull bones, teeth shaped like railroad spikes, a body length estimated around 7.5 meters, larger than almost every crocodile alive today. But the name became the real shock. Crocodylus anthropophagus, human-eating crocodile. Scientists do not casually name species after dietary behavior unless the evidence feels overwhelming. And at Olduvai, the pattern kept appearing again and again. Hominin bones, stone tools, campsites near water, and mixed into the same layers, giant crocodile teeth and bite marks. The implications were difficult to avoid. One of humanity's oldest predators already specialized in hunting us before our species even existed. Olduvai Gorge, around 1.8 million years ago, was beautiful in the cruelest possible way. Volcanic ash drifted across broad grasslands cut by shallow rivers and marshes. Herds of antelope moved through yellow heat shimmer, while flamingos gathered around alkaline lakes glowing pink beneath the sun. During wet seasons, the ground smelled of mud, rotting reeds, and stagnant water baking under African heat. During dry periods, every surviving pool became crowded with desperate animals, and near those pools waited crocodiles longer than a city bus. Early Homo habilis had no permanent shelters, no metal weapons, no boats, no secure boundaries separating safety from death. Water meant survival: drinking, cooling the body, cleaning carcasses, processing plants. Every day required approaching shorelines repeatedly, exactly where ambush predators operate most effectively. Modern Nile crocodiles already kill hundreds of people annually. The attack pattern is terrifyingly efficient. Absolute stillness, eyes barely visible above opaque water. Then explosive acceleration, so fast the human nervous system often cannot process movement before impact. A large crocodile can launch half its body length from water in under a second. Now enlarge that predator dramatically and place it into ecosystems containing smaller, slower, less organized humans. Researchers examining fossil hominin remains from Olduvai noticed puncture marks matching crocodilian teeth dimensions. Some bones carry deep crushing damage, impossible to explain through ordinary scavenging alone. The feeding traces aligned disturbingly well with modern crocodile attack behavior. Grabbing limbs, rotational tearing, bone splintering through immense bite pressure. There is a horrifying intimacy to crocodile predation. Big cats usually kill through blood loss or suffocation. Wolves exhaust prey over distance. Crocodiles erase the boundary between landscape and predator entirely. The river itself becomes camouflage. Safety dissolves into environment. Modern survivors often describe the attack as reality malfunctioning. 1 second, there is water reflecting sunlight. The next second, the world explodes into teeth and violent rotation. That psychological terror may be ancient beyond comprehension. Because crocodilians have hunted primates for tens of millions of years, paleontologists studying ancient ecosystems increasingly suspect crocodiles shaped hominin behavior more profoundly than previously understood. Upright posture may have reduced vulnerability in tall grass, but near rivers, it created new problems. Bipedal mammals bend awkwardly to drink, heads lower, balance shifts forward, limbs compress together at the shoreline. Crocodiles specialize in attacking exactly during those unstable moments. The first humans approached water knowing something beneath the surface might already be watching. And unlike mammalian predators, crocodiles do not announce themselves emotionally. No growling, no warning displays, no chase across open ground. Only silence followed by catastrophic force. That silence matters because the human brain evolved largely around detecting motion, sound, and facial intent from predators nearby. Crocodiles bypass those systems completely. Even modern people experience primal panic near murky water, despite living far removed from prehistoric survival pressures. Swim at dusk in certain rivers, and the imagination activates automatically. Floating logs become suspicious. Ripples acquire intention. Millions of years of evolutionary memory begin surfacing beneath conscious thought. Olduvai's humans lived inside that tension permanently. Some paleoanthropologists argue crocodile pressure may even have influenced the development of social vigilance among early hominins. Drinking alone became dangerous. Children near riverbanks required constant monitoring. Crossing shallow channels demanded coordinated awareness. The cost of distraction was instant death. Unlike lions or hyenas, crocodiles leave almost no opportunity for reaction once contact begins. One mistake ends the encounter immediately. The scale of Crocodylus anthropophagus made escape even less likely. A 7.5-meter crocodile could outweigh a small car while generating bite forces beyond anything early humans could resist physically. Modern crocodiles sometimes store drowned bodies underwater for later feeding. Some attacks leave almost nothing recoverable except scattered bone fragments and drag marks through mud. And Olduvai's archaeological layers contain repeated evidence of humans returning anyway. That detail may be the most revealing of all. Humanity did not conquer dangerous environments quickly. We negotiated with them day after day through necessity. Early humans understood crocodiles intimately because survival required understanding exactly where death liked to hide. Mud color, water depth, bird behavior, sudden silence along shorelines, the curve of reeds moving against wind direction. Knowledge became defensive armor long before metal existed. But knowledge failed sometimes. A child wandering too close, an injured adult moving slower than usual, a moment of thirst during dry season heat when caution collapsed under biological need. The attack would have been brutally fast, water detonating upward, screams cut short, blood spreading across muddy shallows while the crocodile rolled backward into deeper water, carrying the body away. Then silence returning almost immediately, and everyone else on the shoreline forced to continue surviving beside the same river tomorrow morning. That repetition matters because it destroys comforting myths about human dominance. People often picture evolution as a staircase climbing steadily upward toward control over nature. Olduvai tells a different story. For enormous stretches of time, humans occupied prey status inside ecosystems ruled by older, more efficient killers. Crocodiles had already survived multiple mass extinctions before our ancestors shaped their first stone tools. From the crocodile's perspective, humans were simply another thirsty primate approaching the shoreline carelessly. There is also something philosophically unsettling about which predator ultimately receives the title anthropophagus. Not lions, not saber-toothed cats, not giant bears. A crocodile. A creature whose basic body plan predates humanity by roughly 95 million years. While mammoths rose and vanished, while apes evolved intelligence and language and culture, crocodilians remained terrifyingly stable, patient, amphibious, half submerged between worlds, almost unchanged because the design never stopped working. And somewhere in the deep evolutionary past, before civilization, before agriculture, before memory itself became history, early humans looked into dark African water and saw the same thing modern people still fear instinctively today. Eyes floating low above the surface, waiting. For almost the entire length of human existence, our ancestors lived inside someone else's food chain. That may be the single hardest truth buried beneath all 10 of these predators. Modern people inherit a world of asphalt, glass, electric light, locked doors, and rifles visible from orbit through satellite imagery. The average human being can move through an entire lifetime without hearing a large predator breathe in darkness nearby. We mistake that safety for biology. We treat dominance as if it were natural. It is recent, terrifyingly recent. For millions of years, the human body evolved under constant pressure from creatures capable of crushing bones, swallowing children, tearing through camps, or dragging adults into rivers black with mud and blood. The sounds of prehistory were not peaceful. Hyenas cracking femurs in darkness, giant wings beating over open valleys, crocodiles exploding from brown water, primates screaming territorial threats through forests heavy with humidity and rot. And through all of it moved small groups of fragile humans carrying sharpened stone. That is the thread connecting every creature in this countdown. Not monsters, pressure. Pachycrocuta transformed human shelters into feeding grounds. Gigantopithecus forced early hominins to compete with another massive intelligent primate. Haast's eagle proved the sky itself could become predatory. Titanoboa revealed that mammalian intelligence once existed beneath reptiles large enough to consume entire primates whole. Arctodus simus turned open ground into a death sentence. Stephanoaetus showed that even children in trees were not safe. Megalania weaponized ambush and venom across ancient Australia. Dinopithecus blurred the line between human and animal violence. Teratorns erased the illusion that danger only came from the earth below. And at the center waited Crocodylus anthropophagus, the only predator in scientific history named directly for eating us. That detail matters more than it first appears. Scientific names are usually clinical, geographic markers, anatomical traits, References to researchers. But this crocodile received a name translating essentially to human-eating crocodile because paleoanthropologists kept finding the same pattern inside Olduvai Gorge. Human bones, crocodile bite marks, crocodile teeth embedded near hominin remains. Again and again and again. 2 million years ago, East Africa was not humanity's kingdom. It was contested territory soaked in volcanic dust and heat. Rivers shrank under brutal dry seasons, while algae thickened stagnant waterholes. Herds gathered desperately at muddy edges. So did predators. Homo habilis approached water carrying crude stone flakes, scanning reeds for movement. Meanwhile, beneath the surface floated 7.5 meters of muscle and armored patience. Modern Nile crocodiles already kill hundreds of people every year. They do it with horrifying efficiency. No roar, no warning, just sudden force. Water detonates upward. Jaws close with pressures exceeding 3,000 pounds per square inch. Then comes the death roll. Limbs snap. Lungs flood. Silence returns almost immediately. Now enlarge that animal further and place it beside some of the earliest humans who ever existed. There is an uncomfortable pattern hidden across all these stories. Human evolution did not occur because nature gradually stepped aside for intelligence. Nature resisted us constantly. Every predator here imposed selection pressure directly onto the nervous system of our ancestors. Vigilance, social cooperation, memory, tool use, fire, language, pattern recognition. None of these traits emerged inside safety. They emerged because being inattentive meant dying horribly. Even fear itself became adaptive technology. Listen closely to modern human instincts and prehistory is still there. People fear deep water even when pools are chlorinated and fenced. Children fear large eyes staring from darkness. Sudden shadows overhead trigger immediate attention. Teeth displayed in aggression still activate panic. The body remembers environments civilization erased long ago. Our nervous systems were written in predator territory. And perhaps the strangest revelation is this. Human beings survived not because we were strongest. Almost every creature in this countdown outmatched us physically. Faster, larger, better armed, better adapted to direct violence. A giant eagle needed no spear. A crocodile needed no strategy. A short-faced bear could outrun horses. Humans survived because we became coordinated. Because one frightened primate learned to transfer information faster than claws could evolve. A child sees tracks near water. The group remembers. Someone sharpens stone differently after a previous attack. Fire gets moved closer to sleeping areas. Stories form. Warnings become tradition. Tradition becomes culture. Culture becomes cumulative survival. Knowledge became our real apex weapon. That transformation changed the planet permanently. One by one, the balance shifted. Humans learned projectile hunting, cooperative defense, controlled fire landscapes, long-distance communication, tool refinement. Predators that once hunted us began avoiding us instead, then fearing us, then disappearing entirely. By the end of the Ice Age, many giant carnivores had vanished from the ecosystems where humans expanded most aggressively, and silence replaced them. A silence so complete that modern people often fail to understand what the ancient world actually felt like. Because the prehistoric Earth was not empty wilderness waiting romantically for civilization. It was crowded with intelligence, hunger, territorial violence, and evolutionary competition operating every hour of every day. A human being stepping away from campfire light entered negotiations with death immediately. The dark was alive. Even now, tiny fragments of that world survive. Crocodiles still wait beside African rivers. Eagles still carry away monkeys in forest canopies. Bears still stand upright, taller than any person. Komodo dragons still test the air with forked tongues while tracking blood for kilometers. Modern ecosystems are weakened echoes of older systems, but the blueprint remains visible. Nature never stopped being dangerous. We simply surrounded ourselves with walls thick enough to forget. And forgetting may be the most dangerous instinct of all, because these predators force a final realization that reaches beyond paleontology. Human beings like to imagine evolution as a ladder, with us standing triumphantly at the top. But evolution has no top, no finish line, no moral direction. For millions of years, our ancestors were simply another source of calories, moving nervously through hostile landscapes under the eyes of stronger animals. The universe did not guarantee our survival. It merely allowed the possibility. Somewhere in East Africa, nearly 2 million years ago, a small group of early humans probably gathered beside firelight after sunset, while predators moved invisibly beyond the glow. Hyenas laughing in darkness, wings crossing the moon overhead, reeds rustling near water, children pressed close to adults, every sound carrying consequence. And against all statistical logic, those frightened humans endured long enough for you to hear this story today. That may be the greatest miracle in natural history. Not that giant predators once hunted humans, but that humans survived them. If you enjoyed this journey into the brutal reality of prehistory, subscribe to the channel. And tell me in the comments which of these predators would have terrified you most if you had to cross its territory alone after sunset.